Welcome to the Moon and Mars villages. Welcome to the session, the 6th plenary of the IAC 2017. I'm Bernard Coin. I've been the organizer and moderator for this session, and we'll cover themes that include science, technology, innovation, cooperation, security, and inspiration. And we try to code that in colors, and we painted our panelists in various colors as they are going to present this aspect. So it's my pleasure now to invite the panelists. We have just 1 hour. We try to have it interactive, so one shuttle for all to the Moon and Mars. Please go on stage. Jan Werner, Director General of the European Space Agency, and you got a violet color, the color of inspiration. We have Pascal Ehrenfreund, the chair of the executive board of DLR. We got blue color, technology. And so we have David Korsmeyer, Director of Engineering at NASA Ames Research Center. Got also blue color. That's your main one, but you will have also a few other times. Sergei Krikalev is our 6th time astronaut, and he's the Executive Director of Manned Space Flight in Roscosmos. Simona Di Pippo, Director of the United Nations Office for Outer Space Affairs. You got green for this to start with, but that's green is the color of innovation, but cooperation and security will be also along your portfolio. Basically, Professor Taisik, so he's president of KICT until a few months ago, and president now of Exploration Research Institute in Korea. François Rivasso, Director of Security Policy and Space Policy at the European External Action Service. And you got red color, security. So, and we got Monica Johanna Pardo-Spießer, and she comes from Germany and Colombia. So we got many continents represented here, as you can see. And she is, maybe you can stand because she is a winner of a special competition that we held of an Article Prize that was organized by Space Generation Advisory Council and the International Lunar Exploration Working Group. And in this, she is going to present that, but she has the right to go into this panel. And
yes, I will be presenting some slides on what I wrote to be on this panel. So I got this scholarship because I wrote a paper which I presented, and this paper is about bioregenerative life support system. Yeah, I'll be talking with us.
You present that. But how many young Moon Mars explorers are there in the room? Who is above 35 among those? Below 35? Below 35. So she is your representative. As well, we have Joao Losada. He's in Space Generation Advisory Council. He's a regional coordinator, but he's also an analog astronaut. He went on the Moon and Mars, and so he's going to present his work. So, and I'm here, so I will play the role of the moderator and a bit the role of the scientist. Science is in my heart. So let's go to the next slide. So the way we are going to organize it, we want it interactive, but also we want to share some facts. So that's me. So here I cover science and technology. To build the Moon Mars villages, you need pillars. And you have the 6 pillars, and I'm going to ask the various speakers to say, okay, how is your pillar doing? Yeah, so they will make presentation, and they will answer your questions on how we are building towards Moon Mars villages. Next slide. So, the science. We do it also for science. We need science. We want to understand other world, the Moon and Mars, to understand better on Earth. In particular, we have the little brother of Earth, Mars, where we study the interior, volcanoes, water processes, impact, surface. We have been there. There is also water in the atmosphere, here also embedded in the soil. And it has a very interesting water history, very relevant to habitability and possibly to the development of life. And with our mission, Mars Express of Europe, the HIC camera, so developed by DLR, we have got beautiful views in 3D of Mars to study the water history. Mars was possibly a habitable place 3 billion years ago, but it became cold and dry. Did life start there? Did life survive there? That's what we need to investigate. And for this, we have the ExoMars program with one mission that is in orbit now, Trace Gas Orbiter, and rover developed for the mission ExoMars 2020 in collaboration between Roscosmos and ESA, where we are going to look for traces of life underground, where they could survive. So that's for Mars. Also, David will talk about what is done from the US side. The Moon is also a place where you can study the science of rocky planets, to study how they evolve, how they got wrinkles from their internal evolution, how they are bombarded and form impact craters, how you can also establish a chronology in the solar system. There is also volcanism there. We studied also polar region with specific properties of the soil, and we discovered ice there. And we even did experiment where we impacted the Moon with our Smart 1 spacecraft. We call it our baby because we built it at ESA. And we made some of the first maps for the explorers of tomorrow, robotic and human, of the South Pole of the Moon, places where you have permanent shadows and ice, but we even found a place of a peak of eternal light. It would be a great real estate for the future, and we could have an outpost there, just 20 kilometers from the South Pole. So now I wanted to share something also very fresh. We impacted on the surface of the Moon 11 years ago. We looked for the impact, could not find it until just a few months ago, where a colleague looking at images obtained with the Lunar Reconnaissance Orbiter and zooming at the place where our operation scientists determined where Smart 1 should have hit, and that we observed in real time, we found the trace of Smart 1 that bounced on the surface of the Moon, scooped some soil, and created these cars about 15 meters long and some ejecta. So we have found the ejecta and the impact site of a Smart 1. Next step, we need to send a rover there to look for the debris, so that's a challenge to you. And other countries in the last decade developed a kind of orbital moon village, a fleet all around the Moon. So we had the Chinese, we had the Japanese that made the first beautiful map of the gravity field, the Chinese also with images, the first map of the thermal emission. And India, with some of the instruments on board, international instruments detected the surface hydration of the soil. And ELCROSS from the US, with an impact experiment, found that there was about 5% of soil in polar regions that are made of ice. So clearly, ice discovered there, that's a resource for the future we could exploit for institutization, even for fuel for rocket. And we have started a robotic surface village with China that established a lander in 2013 in December that is still in operation. And you see, next steps are glorious. You have a series of missions starting from the beginning of next year, and some do science, some do technology, some do innovation, some are mostly built on cooperation. So we'll have a surface robotic village. We have also humans that will go around the Moon as a cooperative endeavor following like ISS. We have also commercial companies there. And as we have learned this morning, in 2025, we expect to have the first woman on the Moon. Who is the first woman on the Moon here in the room? Who wants to be? Please raise your hand. Yes, we have a few candidates. Oh, okay, excellent. Okay, so now, that was my pitch. We would like to address to you a question, so very fast. What is the top reason for you to go there? Should we do it for science, technology, economy, cooperation, for peace and security, or just to inspire the next generation of young citizens? So let's go very fast. The flash vote. Who thinks it is for science? Oh yes, we need to document this. So we are going to take pictures of you if you agree. Who disagrees? So we take a picture, thanks for your consent. So, and we are going to analyze the result of the road. So who thinks it should be science as the first reason to go to the moon and Mars? Raise your hand. That's question number one. Good. Who thinks that we should do it for technology, development, engineer? Yes, we have a few engineers in the room, that's great. We should do it for economical benefits, for money or for jobs. Oh, okay, we need to get more finance participation in this forum. Or should we do it for cooperation and peace like we did for the International Space Station? Endeavor that unites, a bridge between nations. Or should we do it, for inspiration and education for the next generation? Okay, so we have a very balanced audience. Now the panelists take this into account because you have to do your pitch for this audience that is addressing very many youth and users. So the next one is Professor Jan Waller.
The Moon Village is a very special thing, and I tried to explain it to you, and afterwards come back and tell me you did not understand it. It's my mistake anyhow. So I'm very fond of going beyond low Earth orbit as far as possible, and together with as many as possible. I think this is a clear message. As we heard, if you want to go fast, go alone. If you want to go far, go together. This was what Robert Lightwood said at the beginning of this week, and I can quote him, and it's right. The problem is, if we want today to go to the moon, that we know this, how to do it more or less. You can go there and back within a week, so you can do it during summer vacation. But if you want to go to Mars, you have a very big problem, because if you go with people, you have to be aware that it takes approximately, with today's technology, something like 2 years because of the different orbits, etc. And the issue is, if you have a phone call after 2 days, Houston, we have a problem, or maybe Paris, we have a problem, or maybe Tokyo, we have a problem, then it takes 2 years until you are back. So if you have a health issue, if you have a technical issue, if you have a psychological issue, it takes 2 years. So this is a special challenge, and therefore I believe that for the near future we should first go to the moon, and of course then we go to Mars, and Mars is not the ultimate goal, we go even further. The question is how to go there, and the idea is to go in a totally different way there, not as we are used to do, with a mission, with a project, with a program and all of this, but I propose to go there in what I call an open concept. And to explain what an open concept is, I will give you some notes, meaning what is not an open concept, and then you can find out by yourself what is an open concept, because I always get the question, for instance, when does this project start? But you see, it is not a single project. It has no fixed end-to-end plan. It has not a fully regulated installation. This makes the lawyers very sad. It has not a fixed cooperation scheme. So we are not defining whether Japan, China, India, United States of America, or whoever can participate, whether it's private or public entities. Not a defined timetable. This is worrying many people. But an open architecture, an international community, and to define the interfaces only where really necessary, where needed. And therefore it is a totally different type of space activity, one of the new types I'm proposing for Space 4.0, 1 out of 3. This is one which I think which perfectly fits to the moon activity. The moon is a nice place. If you consider how is a village established, it is not that a government decides, here we put a village, 100 citizens immediately, Lord Mayor, and all of this. A village is founded by the people interested in a location to do something together. There might be a barkeeper, a baker, there might be an undertaker, or whatever, you need something. So they are coming together. And therefore the idea of the Moon Village is an open concept where different activities, international, but also human and robotic, where public and private entities are working together, where we have exploration as one subject, but also pioneering as another one. Therefore it should be inspiring, as it was said already. So an outreach, science, technology, engineering, math, and the A stands for any other subject. I mentioned already the lawyers, the psychologists, the doctors, they are also might be interested in that. It is moon science and cosmology and astronomy. Especially if you go to the far side of the moon, you can have a radio telescope to look deep into the universe much better than from here because of all our radiation we are producing ourselves. Fundamental research and technology development you can do on the moon. Transportation, we have to learn how to go there, how to land, how to go back. And then also the question of communication is something which has to be solved also as a preparation for further mission into the universe. Logistics, resource management. So far we were using always all the stuff we brought to a planet or to a moon, and when we left something over there. In the future it should be the opposite. We are coming there only with a few things, with some instruments, with some machine, and then we use the stuff over there to build structures. And therefore also the planetary defense, which is, from my point of view, a very important issue we should consider, and we can do this from the moon much better than from Earth. Observation is better, but also some mitigation measures. And it should be a stepping stone to go deeper into the universe. Therefore, for me, it's not a contradiction, Moon or Mars or whatever. It is a stepping stone which we can handle with many member states together, with many states worldwide, but it should be always open, and therefore I call it a moon village with free and open access. Thank you very much.
Thank you. So, are you ready for it? Do we have the technology? What are the next steps to do that? So, Professor Ehrenfreund.
Yeah, if I have my slides, otherwise I just improvise. Okay, great. So, how do we go there? We have talked about the destinations, the Earth, Moon, Mars space, which we can also conquer with humans. And we have looked at these destinations, made many roadmaps, and what is really necessary that there is a whole a community of young scientists and engineers which actually enable that we are going there and that we are building a village, a technological village, and later on with humans. And for that, I'm sure many of you in this room are also working in the laboratory, doing simulations in order to understand our other planetary environments and the Moon and Mars in particular. We have to do a lot of field testing, and many people of you have done that, and this is really necessary in order to try to get around on Moon and Mars. And obviously we have also to prepare astronauts for these tasks in the future. And the International Space Station remains a very, very important part of the preparation for going further and building villages on Moon or on Mars. And apart from many different, we have not only one rationales, we need a lot of rationales in order to justify also this endeavor. But it is a very important question to search for our origins and also look at our future. And this is something nobody can take away from us. So I just want to just highlight a little bit of DLR research into this direction, a lunar analog experiment, ROBEX, with many, many German universities and led by the German Aerospace Center. And you see here that we are developing really autonomous roving and lander technology. This is actually an experiment which we did just 2 months ago at Mount Etna, how to deploy a seismological network in order, for instance, later on to measure the interior of the Moon. And that gives you also a lot of spin-off in technology for autonomous navigation, autonomous planning. So it is also something which is really important for future mobility and many other things. And I just want to end. I have been very long the chair of the panel of exploration of the Committee of Space Research, COSPAR, and actually when you go there at lunch you can hold wombats. That's what I just did. They are really, really sweet because COSPAR 2020 will be in Sydney. And there's also a baby kangaroo and a lot of other things I don't remember anymore. And in this transition period towards a global exploration program where all the nations and also emerging nations can participate, we have made a roadmap in 2012 what are the stepping stones and how can we work together? And there we, for instance, identified an international Earth-based field research program where all the programs from all the world actually work together. We called it at that time EarthX. And of course, having a really concentrated program on the ISS with many nations together for preparation of those large endeavors to Moon and Mars. A SmallSat program, as you see, the robotic village has always been around, and a giant sample return mission where actually the large space powers work also with emerging nations in order to do capacity building and get the whole environment, the whole world more or less inspired with science, and of course later on leading to international human bases where we can learn from how we work in Antarctica. So this is a little bit a broad spectrum which I think is really important, the way to go there.
We can also attend questions. We have some assistants. You will find them in blue. They are there. So if you are interested to ask a question, please raise your hand. They will bring you a sheet that will be brought, and we will answer your question in the second part. Actually, we received already a question. What is NASA doing on Moon and Mars mission? And David Kosmeyer from NASA.
Thank you. Thank you, Bernard. So, Mars today, as was mentioned by Acting Administrator Robert Lightfoot earlier this week, Mars is the penultimate goal for human exploration for NASA. That doesn't mean that there's not lots of other wonderful places and things to do, but this is where we think the next human exploration activity should focus. Just like the current human activity focuses on low Earth orbit and the International Space Station, Mars today has had near permanent robotic activities on it since 2003, the end of 2003, when the Mars Opportunity and Spirit landed. There are over 4,800 sols of activity, which is a Martian day, continuous robotic activity ongoing on Mars. Opportunity continues to do its exploration. 1,800 days of continuous robotic exploration of Opportunity and Curiosity as it's climbing the hills and looking for signs of water and additional life venues. We have additional opportunities that have come through the Phoenix rover that landed and drilled for water ice, found it carbon dioxide and water ice on the South Poles, and we've had multiple missions since. MAVEN, multiple orbiting assets, the Mars Reconnaissance Orbiter, Mars Odyssey, Mars Geographic Systems have been continuously mapping the surface of the planet. So there is a robotic village there, and NASA's not the only player. We've had Indian and Russian and soon to be, I heard there was a mission being planned from Dubai. There's many wonderful opportunities for all of the agencies working in space to use Mars as kind of a staging point to go out and push human exploration. One of the things that we didn't talk about, or I don't have a slide on, I don't believe, is on the lunar side of things. NASA has been using the moon as a great technology testbed for future opportunities for the Mars activities. We are sending out 12 small nanosats in addition to the large SLS Earth Moon 1 mission, which will be launching in about 2020. That's going to send out 12 to 13 small nanosats. They're going to go in lunar vicinity and test various technologies and provide great opportunities for academia and industry to get engaged. NASA's been looking for resources to validate whether or not we can use some of the volatiles, the ices on the moon, to make future exploration for humankind. So there's lots of great opportunities there, and NASA's shouldn't be doing this by themselves, doesn't want to be doing it by themselves, and is looking for partners like we have in the International Space Station to work collaboratively, and so we're very excited to participate. Thank you.
Thank you. So we start to receive some questions, but one of them is, so what is Russia doing? And Sergei, are you going to the moon?
Well, I probably will return to original question, so what was what is more important? What is most important part of this activity? And I think talking about villages, maybe it's different in different languages, different of the same word can be a little different. But for me, first of all, village means people. And if we are going to set some kind of village on the moon, maybe in moon vicinity in the beginning, then on Mars, that probably means that we sooner or later going to set people there. People will do probably different tasks because, again, in the village everyone is doing things a little different. Some people harvesting, some people do machinery, some people raise kids, and we probably will do something different in these villages. But again, if we are going to move forward, sooner or later we need to put people there. Second question was in the very beginning, what is most important for the villages? My answer would be inspiration, because we don't know exactly what is going to be, how this village is going to look, which way we are going to go, and what Jan Varanus said, that it's going to be open architecture, it's going to be not very certain plans, and very often people ask when and how we will go there. I think we are already on this path, because even talking about Korean program, originally it started as simple international cooperation in only one task, and then it evolves from one program to another. It starts in human space flights, at least. It started from Apollo-Soyuz project a long time ago, and then it was joint flights, and then International Space Station. And now we are using space station as a test bed for future missions. So I think the same way we will use Moon Village as a test bed for Mars Village. And I think we are changing program. Dates are changing also, and technology is changing. So for sure we will use robotic parts of all these missions, and that's what we are planning and doing right now, because we are already doing robotic exploration of Moon and Mars, and we are planning next missions robotically in the beginning. And very often people start to argue what is most efficient way to do this robotically or using humans. I think finally all our space engineering community is coming to conclusion that most efficient way would be to have combination, robotic and human missions. So I think we are already on the way, and setting interesting target is inspire people who will not only work in the future in these villages, but for people who will make this path realistic, and that's probably all of you. Thank you.
Okay, thank you. We start to have some questions. I want also to indicate that who wants to go to the Moon and Mars? Raise your hand. Oh, everybody. We'll have scientists, engineers, we'll have medical, biologists, we'll have artists. Here we have with us an artist, Sylvia. She is already artist in Moon Mars residence, and she's capturing the discussion of today. She has some pillars from Earth reaching the Moon and Mars. And the pillars are science, technology, innovation, cooperation, security, and inspiration. And now I'd like to invite Simonetta Di Pippo to talk about the cooperation and security pillars for the Moon Mars Village.
Thank you, Bernard. Welcome, everybody. It's really a pleasure for me to be here today, because this is quite an important opportunity for me to share with you a little bit what the United Nations and United Nations Office for Outer Space Affairs, what we are doing in order to follow what has been already presented, and which means trying to create an open and free environment for the future exploration of the solar system. And we are trying to do that in a way that is not involving only member states, is not involving only space agencies, not only spacefaring nations, but also the private sector, but also other communities, not necessarily linked to space today, user communities, civil society, academia, NGOs, everyone, everywhere. Looking in particular to emerging and developing countries and trying to help them towards a sustainable development approach for their life on Earth, looking at exploration and innovation, because innovation is embedded in the word exploration in a way. So, indeed, we can talk about cooperation and security, but I would say that if the question of which is the main reason why we should explore, I would say is because of science, is because the research we can do, is because we are developing. When you have a challenging objective, you have developed disruptive technologies, so it's technology, it's innovation for sure, it's cooperation, because as I said, we cannot do it all together. I mean, the only way to do it is all together. It's security, because when you work together in a sort of space diplomacy approach, you automatically solve a lot of issues on Earth, because going beyond the Earth limit together means a lot for everyone, everywhere again. And then inspiration, we've been talking about STEM education. We look at diversity, we look at women to be involved more and more. We look at youth, we looked at everyone, everywhere, as I said, because one of the main motto of our 2030 Agenda for Sustainable Development is that no one has to be left behind. And for sure, the approach that we are trying to put forward in preparation of Unispace Plus 50 is at the same time top-down and bottom-up, because you need a structure, you need a governance to be able to embrace everyone everywhere. And we are ready with this. When this framework will be settled, we can be ready to listen to everyone, to all the comments, to all the inputs, to all the contributions. So in a way, it's really similar to what Jan Werner was presenting. It's not a project, there is not a clear timeline, but it's more a global framework where everyone can contribute to the future exploration of the solar system, which means bringing the human species beyond the Earth limit together. It's, as I said, innovation, but it's also mainly cooperation for diplomacy. And we could discuss about these topics for 24 hours, for sure. I have just a few minutes, so I know that Bernard is very keen to keep the time, but if you have, after this panel, any comment or any question, please don't hesitate to contact me. Thank you.
Yeah, are we ready? And actually, I have a question here. What type of infrastructure we need? What technology development do we need? Are we ready? And that fits quite well. Some new technologies are being prepared, and so that how can we use some of the civil engineering experience on Earth to build also construction on the Moon and Mars? And that's addressed by Professor Taisikli.
Good afternoon. This is Taisikli. You have a question. Are you ready for the construction from Korea for the Moon Village? Yes, we are ready, because we select the Korean president last name is Moon. And also science advisor's last name is Moon too, so we are ready for Moon's Village. Korea is a very strong construction industry. We are the sixth largest construction industry in the world. So that's why we started the construction, Moon construction. This is our design. My friend is Sam Simmons. And this is the largest in the world dirty vacuum chamber. We call Moon and Mars Environment Vacuum Chamber. Why we call it dirty? Because usually physicists and then chemistry people like without dust in the vacuum chamber. But for the Moon and Mars construction, we need the moon soil and also dust. And this chamber is a size-wise 4 meter by 4 meter by 4 meters and 50 cubic meter. And minus 190 degree plus 150 degree. And without soil 10 minus 8 torr, with soil 10 minus 4 torr, and then radiation, and then day and night, you can use it. So this one can be used by NASA, ESA, Canada Space Agency for the all the assembling equipment for at the dirty vacuum chamber. My team, as a winner at the Phase 2 3D printer habitat Sentinel Challenge from NASA, that is my team, and that is we call the Lunar Crit. The bad materials, concrete, especially cement, is the bad material for the CO2. 40% of the CO2 from the building and pavement, anything. But this we are using the volcano basalt. That means for making the cement, you should fire the limestone, but the volcano acid is already baked by the volcano. So you can use these materials not only Moon and Mars, but also we can use it for the Earth. You can make the hopefully $3,000 for poor people housing very soon. And then you can see the down all over the world, 77 teams, and then the finally is only 3 finalists, and we are the 3rd best score in the world. And the last part is our 3D printer, very large, 2 meter height, and then 3 meter and 3 meter. So next year, NASA will Sentinel Challenge again. That time is a real scale, 10 meter by 10 meter by 3 meter building for Mars. So anybody are interested, please let us know. And KPLO, we have a plan 2018, but we changed it 2020. And then the lander and rover will be on 2023, hopefully, otherwise 2025. And you can see that you can test the Extreme Construction Research Center. And also, you can use the lander and rover inside the vacuum chamber, dirty vacuum chamber. And then we will go to the, by the way, the mining industry, you know the aerospace industry, but the mining industry already make the committee from Australia and then from the Canada. They want to make mining industry on the moon. So that time, we need the landing site. We call spaceport, not the airport. The reason is there is no air on the moon. And also many habitation we need. And as you know, the Mars One from Netherlands, they will send the 100 people for the Mars in 2030. We know 24,000 people apply. Right now, the 800 people are trained, and then finally 100 people will be there. So the final destination is radiation shielding. So we may stay in the lava tube on the moon or Mars here. So I will talk about if you have questions, let me know. Thank you.
Thank you very much. Indeed, we fly over the moon and Mars, but there are all these beautiful technical sessions where some of these aspects are being discussed. Go to the technical sessions as well. Let's move to security. And actually, I have some questions on cooperation and security while François Rivazan is coming to stage. Okay, how does going to the moon and Mars promote peace, and how to avoid to put weapons of mass destruction there?
Hi. I'm supposed to be the security guy, so to speak bluntly, and I have to say that, for example, Jan Vernier encouraged me to be blunt. So let's be very blunt. In the EU space strategy and following documents, and ESA documents also, there is always 2 aspects in security. Security from space, what security benefits can we get from the moon and Mars villages, and security to space, how to ensure the security of these villages. I shall be very blunt on the first point, security from space. I don't want them. Why? Because if you expect security benefits from the Mars village or the Moon village, it means that it will have to be taken into consideration by all the military planners in the world. It's just like that. I'm a diplomat, but I'm what you would call a Paul Mills diplomat. That's it, I've worked mostly in my career on military issues. I can tell you it cannot be otherwise. So forget, please, about stacking weapons there. Forget, most immediately, about putting backup functions for our Earth orbiting solutions, something which would be more feasible, possibly. Forget about security benefits from Mars or Moon villages. I know that there will be some, unavoidably, which will be very tempting. For example, on the Moon village, you could think that a Moon village would be helpful for space weather predictions, which are heavily military, as you know. But, well, that maybe cannot be avoided. But don't rely only on that, because immediately you will have military taking interest in what happened in these villages, and then the problem will change completely, and instead of being peaceful things, there will be things that will have to be protected militarily. They will be not open to cooperation in the same way. We will lose the very inspirational value and cooperative value of these villages. We could also think, for example, and this is maybe more easier to conceive in planetary protection, because there's good observation from the villages. Okay, some indirect benefits, why not, but not strategic benefits. On Mars villages, for example, you could think very easily on very interesting ecological and environmental security benefits, because for climate change, for all the science benefits there's a lot of things to do. This is easier to accept. But basically, I would say, don't forget that each time that you speak about security to the Earth, you take a risk. Security now of the villages, second aspect. Security of the villages, we will need security specialists. And I will join my Russian colleague and I will make a bet. If there is only one person living, a human person living in the village, it will be a security specialist. Because, as you know, in Mir, in the ISS, there are a number of functions that robotic cannot be done only by robotic means. Look at Philae. Well, if we had had somebody to repair it, to push it just 1 meter further, it would have produced probably better results. The high level of investment that we shall have in the villages makes absolutely necessary to maintain them and make a human mission to this place probably less costly than to lose all these investments. And think just 1 second, just 10 seconds more. Just think 1 second about the kind of capabilities you will need in a village. You will need first, obviously, specialists of protection of human life, protection against debris, asteroids, radiations, hostile conditions on the planet. You will need also energy security specialists. Some speak about sending a small nuclear reactor to produce energy immediately, or solar panel. Well, is it somebody of IEA here? We will need a nuclear energy specialist in that case. Surely we will need cybersecurity specialists. I'm in charge of cybersecurity also for the EU, and I can tell you that it is obvious that you will need a cybersecurity specialist there. And if tourism is developing, if, for example, people go honeymooning on the moon, I hope some of you will have the opportunity to do it, maybe for the youngest of you. So why not? We will need probably some kind of policeman or security guy, like in a plane, to avoid that tourists endanger the infrastructure. And last point on that, if a village are developing, you will need probably, if we see more people, you will need probably also a sort of kind of diplomatic capability, because we will see people from Eastern Timor to China to South Africa, and to be able to understand all of that and to be able to cope with all the different cultures approach, you will need a diplomatic function. So, you know, if you are seeking for a head of the security section in a village, you have already my candidature here. Thank you. Very good.
Okay, security first, and we expect a good contribution from the security budget of our planet to the exploration of the Moon and Mars. Now I have a question, but when are we going to be able to self-sustain Moon and Mars villages? to live off the land. And that goes very well, because that's the subject of Joanna here.
Thank you. I want to start with my master thesis, which is an example on how to inspire and engage younger people and young engineers in Moon and Mars affairs. I was given the opportunity, the chance to do my master thesis at the European Astronaut Center within the Spaceship EAC initiative. Spaceship EAC is an initiative which fosters different exploration activities in many different areas. It's an initiative where students can do research and where they can operate different technology platforms, and it's an opportunity for them. And for me, I was in the little pink dot, which is life support, and I had the opportunity to work on a life support system, which is CROP. CROP stands for Combined Regenerative Organic Food Production, and we had two demonstrators at EAC where we, in a short sentence, grew tomato plants with the help of synthetic urine. Yes, synthetic urine. And we had the synthetic urine recycled through the crop filters, and it was recycled into compounds, into nutrients, which could be taken up by our plants. It is a hydroponic system, so the water flew from the tanks to the filters and then into the growth chamber. On the right, you can see how it really looks like from the front and from the back, and this is the kind of experiment and this is the kind of innovation you would need if you want to go to the Moon and Mars, and especially if you want your astronauts to eat fresh food. This is what you need: recycling waste and being able to produce fresh food. Thank you.
Okay. So indeed, a lot of some challenges for Moon Mars Village implementation, to get there, communicate, operate, go with the move, and go with the rovers, and have a backup system, humans, robots, to the service of users. And here we have a Moon Mars analog astronaut that has tested some of the systems in real life on Earth. Before we go to him, actually, you prepared a question for everybody. So what do you think is a major challenge towards the Moon Village, or Moon Mars Village? Technology, space transportation, collaboration, and engaging non-traditional space, commercial opportunities, or awareness. Let's get a flash vote. Who thinks it's technology? Raise your hand. Okay. Oh, okay, so there are a lot of engineers, they can sort it out. Space transportation, are we ready? Do we have the rockets? In the panel, do you believe that we have the space transportation we need for going to the Moon and Mars? What are the plans?
Mars not.
Can you, you can use the microphone. Mars, we are not ready, but clearly, as Jan demonstrated, we can go around the Moon. Actually, we need a cooperation for this. We need the ESA service module bringing the Orion capsule around the Moon. Sergei? You wanted to say something about transportation? Oh, okay. So, and we think it's more a problem of working together, collaboration. Okay. So that's a message for us. And engaging non-traditional space. People with new ideas, people with a lot of money. Yeah. Okay. And also develop new business. And or maybe we have to be global, have a global awareness of what it means for our humanity to go to the Moon and Mars. Okay, so, well, this is a challenge for you.
The good thing is they don't see big challenges, so we can do it. This is my response from what you did. You did not ask what would you like to do, you asked what are the major challenges, and all of the questions did not get the big majority. That means, let's do it.
Yeah, let's do it. And so let's now have a Joao that will tell us on Earth how we can already prepare for it.
Good afternoon, everyone. My name is Joao Losada. I am lucky to be part of two volunteer-based organizations, the Space Generation Advisory Council and the Austrian Space Forum. And I was lucky enough to be part of two analog missions with these two organizations. And For those that don't know what analog missions are, they are basically missions set here on Earth that look into places on Earth that are similar to the planetary body that you want to study, and that can be either geologically similar, can be in terms of temperature, atmospheric conditions, or others. So this is not a new field of research. These are Apollo 16 astronauts John Young and Charles Duke Jr. preparing for their Apollo 16 mission, performing analog geological work. And this is me doing something similar in Austria, doing astrobiology research. And that's what analog missions do. So they allow us to test technologies and procedures, as well as human interfaces that we might need on those planetary bodies. And they allow us to do that at a fraction of the cost. So I was lucky to be part of these two missions. One is called PIMAS from the Space Generation Advisory Council. We were isolated in a habitat for 2 weeks, where we looked at how we can survive and how we can perform experiments in this isolated environment, and also looking at the psychology effects that we would have in this case. Another mission was MAD-15, taking place in southern Austria in the Kaunertal region, where we looked at the rock glaciers that they have there, and they are geologically similar to some of the rock glaciers we have on Mars, and so we looked at astrobiology and to define this geology set. And for me, most importantly as well, is what we have on the background. These are the mission support teams. And these are people usually from different countries all around the world. Usually we have 40 to 50 people joining in each of these missions from different nationalities, coming together and working as a team and making this mission happen. Also in the Space Generation Advisory Council, we organized several Moon Village workshops. I actually got an email today that we're organizing the next one in Budapest, together with the Space Generation Advisory Council. That's October 31st, so exciting. And just to wrap up, I think it's also very important, the inspiration and this outreach. And for those of you that have talked with children before and gave a lecture in school or something like that, I think you know what I mean when I say that it is really a unique feeling when you see the inspiration and the spark in their eyes, and you hear the curiosity, the innocence of these children, and how you can spark this curiosity. And I think that's really amazing, and that's one of the things that we can get the most out of these analog missions, building towards Moon-Mars villages. Thank you.
Good. Our Watcher challenge in 1 hour to go through all this diversity of experience and input. So we have a number of questions here. Some of them were captured before. So what are the questions you want to ask first? Do you like the first, the second question? Well, we covered them. Okay, what did we do for question 1? What are the current Moon-Mars plans that we didn't describe? So what is the next step for humans? So, Eliane?
So for the idea I presented, it's clear that there should not be a big plan for it. There should be just the announcement and the declaration, and we are, in this week, we are collecting signatures, not binding signatures as for a contract, because that would be again against the idea of an open concept. We are just asking institutions, public and private, worldwide, to just declare their interest in this. And this is to found a village, it's enough. And then ESA is not the organization which will be mastering and will be the master of the game. We don't want to do that. We are ready to support, we are ready to be the enabler, the mediator, maybe also the broker. For instance, we know right now, and we get this information, there are companies providing transportation to the moon. ESA itself is also asking now also industry in an announcement of opportunity to give us information what they would like to provide and what they would like to deliver. So we are looking for organizations, and we have now already something like an archive or data storage where institutions are telling us, okay, we will go to the moon. We are ready to take some other also to the moon, an organization which has not the capability, so it should not be a question of money, whether you go to the moon or not, if you have a scientific instrument or whatever. others are offering full transportation capabilities. So therefore, I think there should be not a plan. We should try to coordinate, but not in a regulated way, but to collect the ideas, to play the role of a broker, and I'm really happy if we have many different actors playing in that scheme. So
okay, thank you. We have to stick to time.
So it's working.
Yeah. So let's get the others also on this first point, because we want to address. We have only 4 minutes left. 30 seconds answer. Anything on the first question? Move on to adopt. Adopt your question. What question you want to answer?
Well, I take the last one.
Yes, okay.
Because I think this is something which is really very typical for the IF. You know, this is a conference where all the stakeholders meet. It's very rare that you have even a whole bunch of lawyers, you know, together with the technologists, engineers, scientists, and people which are here for promotion and communication. And I think it is really important that stakeholders mingle and exchange their ideas in order to really collaborate to come up with a plan. Because that is necessary in order then to convince people with budget authority. And I think this is something what we should also really practice at this conference, IF, and I don't always do that, or only do that because I'm a vice president, and I'm really vouching for that.
Okay, so what question do you adopt?
So number 6, the infrastructure for the Moon and for the Mars activities. One of the things that NASA's beginning to look at is the distant retrograde orbit, so the Deep Space Gateway. It's kind of the high ground, so once there, you can easily get to the lunar surface, you can easily get to Mars surface. You've expended the energy to get to the high ground and then place any resources you have. So it becomes really a node, a transportation node, and we view that as a great opportunity for extending perhaps station activities and extending humans first there and then wherever else is appropriate to go, the surface of the Moon or Mars.
Oh, like we had a command module for Apollo that was supporting the function, but we spent most of the money on the landers. So if you don't spend all the money on the Deep Space Gateway and at surface infrastructure,
you need to be careful. That's correct. Yes, absolutely.
Okay. So, Sergei.
Well, in general, maybe about question number 5, or actually all of them sometimes intersecting. I would say that setting a very interesting task for us is very important, because as soon as we have an interesting task to reach it, to reach this goal, then we will set cooperation, and the station is a good example for that. That's what we just discussed, that there is no policeman on the station, because everyone is trying to execute joint task, and we don't need to discuss small details or plan them in advance. As soon as we have interesting task, we will find a way how to solve it.
Okay, Simonetta?
Number 7, we cannot have a role for small or emerging space countries or developing countries and new partners if we don't find a way of having a global governance allowing open and free access.
Good.
Number 2, how many younger than 30 years old right now? Many. Usually the agency has the average age is 45 to 50. So we need to prepare the young age like you, and so we need imagination for them, especially high school and the middle school. And 245, my friend gave the paper, STEM program, and his name is Sam Siemens, and the title is LCAT. So that high school program, so you can come and then join us. Korea and Europe, and also many countries are applying for right now. So young generation is very, very important.
Yeah, the Moon Mars Village is getting viral, huh? Thanks to you, tweet and go on social media. So, François?
Yeah, on question 5, it's obvious that we have to use science research, as it has been said by my Russian colleague and by Simonetta. It's the only way to promote peaceful use, and both villages offer distinct scientific field of experiences on the station, and it's also sure that we will have to find a way of governance associating more universally the whole planet to this program of research.
Yeah, Joanna?
Right. I'm also taking number 2. And I have a concrete recommendation to a research, a citizen research project with Moon Mars data, something like Planners Hunter or Galaxy U, or my favorite, the SGAC Search and Asteroid Campaign. Do something like that with Moon Mars data.
And Joao?
So I'm going to give it a try at number 8, how to collaborate effectively between countries and agencies and partners. So I think it's already something that we do in these volunteer-based organizations where we try to involve people from different countries, and in these missions that I was referring, we have people coming from places all over the world, some of them without even a space program, so without an opportunity to actually work in the space area. And so I think trying to involve them, and all of them have different expertise, and I think the way forward is to try to involve all these partners, all these people in all these countries that have this different expertise, and together they can create something really unique. And I think we can build on what we learned with the ISS, where different agencies came together with different expertise. And I think we can build on that established partnership and definitely move forward towards this Moon Mars Villages. I
want to thank you very much for being here, for audience, for your participation, your vote that we are going to compile. And I want also to thank the panel. I believe that there was a strong interest, and next year in Bremen we'll do something different, but with other actors, but I think there is a very strong interest in these topics and how we can establish Moon Mars villages building on these pillars: science, technology, innovation, cooperation, security, and inspiration. And I recommend you to see what our Moon Mars artists in residence has produced to document, and please share what you have seen here, and go to the technical session and those events. Thank you very much for being here, and